Right, so this is the power amplifier assembly out of the Fluke. Now, I suspect there's a fault on this board, but I don't know for sure. Now, the overload indicator on the unit stays illuminated all the time. That indicator is driven from this board. May also explain why there's no output. So I want to test every single component on this board, just to see where there may be problems, or what's going on. It could be bad transistors, or bad capacitors, or anything. There's a couple of caps here. There's some tantalums tucked away under there. There's all that. So it's quite a hefty board. It's actually got a big heatsink on the back there with some big power transistors, and the parts look like they just plug in as like posts in between there. Don't think you can see it, but there's little posts in there which is like they plug in together. So it looks like I've got to take some screws out this top board here, and I should be able to lift it off. At least that's the way it appears. Right, so I've just taken that screw out. I thought I'd better record this actually, because some of these have got these big standoff posts. So the corner ones have got the big standoffs, and there's just a single screw in the centre of this other ones, which is shorter. Let's get this wire out of the way. Hold on a second. Okay. Right. So I'm hoping that I'm correct in the way this thing comes together. Now there's some screws down the centre here, which look like it binds the board onto the heatsink right by the transistors, so there's a good connection there. Because that's what it appears to be like. I haven't done any physical testing, like test points or anything like that. I haven't done any kind of testing at all, but I want to pull it apart and hopefully that's really tight. It's not one to undo. That one's doing. That screw there doesn't want to come loose, which is a little bit concerning. I'll have to give it a tap. So I just need to give it a bit of an impact and it will free up. Here's another one which is also really soft. And that one there. So I've got a few here which I need to look at. Might even try a different screwdriver which fits slightly better. Let's see if there's any other ones I need to take out. There might be inside that cover there. Need to look at taking this off and have a look at that too. Well, by putting the bit into the screw and giving a bit of a whack, I've managed to get this one here out. These two here are really stuck. I'm having a real hard time getting them out. They're actually rounding the heads off, trying to turn them. So these are going to be a bit tricky to get out. I might have to drill them out, unfortunately, but I hope I don't have to resort to that. Alright, so I've got a crappy old pair of cutters here. Got lots of dings and stuff out of them. Not very good. But I just managed to get that one there to break. That one just started to come. Yep, that's that one there. Can actually get into the sides of it, grab the sides and get that to break then. But yeah, that I need to find some replacements obviously. So that leaves just that one there. So let's see how lucky I'm going to get again. Try and dig it into the sides a little bit. Reduce how much it's going to slip by. I'm worried about breaking the bloody circuit board, to be honest, but it's not the easiest thing to grab hold of. Yeah, got it. Got it. You know what a mission that was. Yeah, so we can get into this one now. Yeah, that'll work. Where's the rest of it gone? Here's this one. I'm trying all different screwdrivers and trying to ram a screwdriver into it and that sort of stuff. Anyway. Right, that was a mission. But I got them out. And I haven't damaged the board. Yay. What a mission that was. Could have done without that, I have to say. Okay, so now this should lift off. Now I noticed when I took these screws out and started wiggling this board around, all these little standoffs, well, these little locators here, they all just broke off, they're all broken. So I'm going to have to reattach all those. One side seems okay, the other side not so much. So let's see if I can pop this out now. So it all sort of plugs in, it seems. Just trying to wiggle it around a little bit. There's all these connectors down here. So there we go. That's those. So any more? There we go. Right. She's out. Bad solder joint just there. And that resistor. That might have been getting hot. All this flaking off a little bit, which is all rather interesting. Yeah, that was a mission getting that apart. Wow. But it needs to be done. I mean, these are all contact points, right? So these have to be done down tight to make those connections. So, you know, it's one of those things, and you just have to have it. Must be getting hot here. It's hot there. A couple of bad solder joints there. So some clues. Bit warm around here, a bit of discoloration, but it's not too bad. But certainly that, I mean, I just expect that to get hot anyway, so that's not heat sinking or anything. But this one over here probably shouldn't be getting that hot. There's just like that part there, which is a diode CR4. Looks like it's been getting hot, and you would expect that to happen. So I've got a few things to check at least. What I might do is check this assembly first, just to get the big one out of the way, and see how we go with that. Okay, let's get some power. I've got no idea what these pinouts are. I guess we'll figure it out as we go along. Diode. Those joined. Those are joined. Yep. Okay. It's 0.56. 3.2. So it's probably common that way. Yep. Set a bit of base. Let's do this one here too. 0.47, probably the same deal. Yeah, 0.51, so there's a starting balance here, it's probably okay. 0.5, 0.5, showing nothing that way. Nothing that way, so it might be an NPN device or PNP. Inverted the other ones anyway. Looks okay. That looks okay. So all those power transistors on that heatsink look good. No issues. Alright, let's start checking components now. Although I pulled off the heatsink, I'll need to get to the back of some of these parts, so I'm just going to go through the whole thing. And I'll try and do it quadrant by quadrant, I suppose, but I'll just check all the main semiconductor parts first, then I'll look at other stuff afterwards. Let's go that way around. Looks okay. It's okay. 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 There's a diode there. Can't see which way that goes. That's interesting. Looks okay that way. I'll check all the diodes first, and I'll go through afterwards and check semiconductors. Then I'll check capacitors. Try and do it in a logical sequence so I don't miss anything. I'm only checking in one direction. I mean, usually that'll tell you if there's an issue. I mean, usually they short or open anyway. A lot of times they're short, so you'll see it which way around you connect the probes. I don't often check in both directions, as I'm checking for characteristics to make sure it's definitely okay. That looks like a diode there as well. Not sure. No, that's a diode. Getting 0.6 there. This looks like that part there. Diode, there we go. I can see the marking on there now. There we go, that's fine. This looks like it's been resoldered. That's been soldered. So someone's been working in this section here. Yeah, someone's been working here. Very interesting. Anyway, we'll just carry on as I was, checking individual parts. I can't see what I'm doing too well. Right, 5. So 5 diodes are okay. Do some more this way. Right. So I'm suspicious about some parts over here, so we'll see how we go about those. Well, that's showing 0.2. And the same in the other direction. I'll have to check on that one. To make a note. Where's my pen gone? Right. I don't know what diode that is, I can't see. What's that? Next to C35. Carry on. Diode there. Looks okay. Looks okay, and that's the one that's been getting hot. So that's probably a Zener anyway. Probably a Zener diode, most likely. Looks okay. It's okay. Fine. What's that? It's a diode too. It's okay. Nothing so far. Okay. There's a diode hiding down there. Yep. One there. If I miss one, someone let me know. It's alright. It's alright. It's alright. Oh, these ones here. 0.13. Same in the other direction, so those I'm a little suspicious about. But then there's a pair of them given the same reading. I have to look into those ones. So that's one's next to year 2. And oh, there's one there. That's fine. So I think that's all the diodes. So far so good. Alright, so let's look at all the transistors now. So some of these are actually in sockets, and I'm tempted to pull them out because it will, at the very least, it will allow them to reseat and make sure they've got connections. Because it could even be that it's a bad connection to a socket. That's certainly possible. So anyway, let's start with this one. 6.9. That looks fine. Anything looks out of whack, I'll check in the other direction as well. I'll do the simple parts first. It's 0.37, that was looking a little bit lower. And 0.9 that way. That's probably because it's in circuit. Let's pull that one out. Hopefully without breaking the leg off it. Okay. 2N390 something. 3904. Okay. So I remember I ordered some of those. So if that is dodgy, I can replace it. Let's just check this. 0.6 that way. 0.6 that way. No, that seems fine. Breaking again. Doesn't want to plug in too well though, I have to say. Doesn't seem like it's actually plugged in very well. Well, that's part of the issue with it. Let's just try and get it a bit better. Could be this has been replaced by someone at some point and it's not quite been aligned correctly. You know, you never know. Okay, right. Well, it seems to be kind of in there now. Still not 100% happy with it though. Don't trust sockets, I really don't. Let's just measure that from the back. It's 0.6 there. 3, yeah, I'm getting readings there anyway, so yeah, I think that's about right. Just don't trust them. Well, I've got this way, might as well check these other ones actually. So we've got one just here. Don't slip, it'd be good. 0.67, 0.9 again, I'm getting that slightly odd. That's 0.56 there. 0.57 there we go. Where's the another one? Over here, wasn't it? Is that? That's what I've just done. Over here. I think that's going to be the base there. 0.6. 0.6, that one looks alright. There's one over here, two over here. Showing a 1. 0.75 could be a reverse polarity, could be an NPN versus PNP. 0.6, 0.6, 0.65, yeah. Okay, so those are all looking okay so far. Got to check this one here. That one there. Don't know if I did that one or not. Check it again anyway. 0.6, 6. Oh, that's got a very low value that way. Might be different pin out. It's a very low value across those two. Let me have a little look at that. It's in a socket, so let's pop it out and have a look. Hopefully it will wiggle out quite nicely without breaking. So the thing that worries me most about these is trying to get the things out without breaking them. Okay. Check it out of circuit. Try and check it out of circuit. .64. Nothing that way. 0.64. So must just be something in this circuit near it. So that one looks fine. Put that back in again really carefully. There's one over here. You might pause this a second. Right, and just there. Let's try this one. Yeah, that one looks okay. So let's carry on. There's a big one up here too. Let's check that. This one actually looks like it's got a bad solder joint. I can see a ring around it. That's got a bad joint. See if we can see it. So just there. You may or may not be able to see the ring around it. See it? The leg right there. See that? Bad joints. So that could be related to the problem. So measure it again. Yeah, it measures okay. Let's just fix those joints while I think about it. And I'll carry on testing those other transistors. A couple of smaller ones around which I've missed. One there which I've missed. Those ones there, let's just check those. Ah, that's showing a short. Other direction, also showing a short. So this one here, Q19, looks like it's bad. Potentially. Q19. Could be due to circuit around it. There is a resistor, and yeah, a couple of resistors there, so maybe, but yeah, well, it's not showing dead short because it's not beeping. Did I check those? I think I did. Let's check them again. Yeah, like that. Don't be checking myself either. Best to be sure. Done those, done those. I haven't done this one. There's one up here. Which is a little tricky. That's also shown as a short. That's shown as a short. What's that one? Good question. Actually, that looks like a There's a mark in here of CR17, so it's showing as a diode. I don't know, maybe something else going on there. I'll mark it anyway. CR17. Trouble testing in circuit, you never quite know if it's actually the circuit or something else. If you get a weird reading. I'm guessing this is PNP, NPN, is it? No, I'm getting a short on that one as well. Q7A. What's something to do with all this stuff? Actually, look at this. See this? There's no solder list coming through here. There's holes. It's probably been replaced, or it's not installed properly. So there's a few things I'm getting to find now. This on these smaller parts. Let's check this one over here. Not a short. So someone has been working in this area too. So what is that one? Can't see the number. Is that Q14? Looks like somebody had a diode. I think it's Q14. So some progress. I've been finding some stuff now. Alright, at least some things to check. Alright. Let's just fix that bad solder joint before we move on. Forget about them. I'm not going to clean anything off yet because I want to see the bits I worked on. Alright, there's definitely issues over here too. So, okay. Pause again. So I've got to try and keep these videos down to 5 minutes in each section so that my audio doesn't go out of sync. It's a bit of a pain, but there's not much I can do about it. Just the way it works, fortunately. See if I can get some props underneath here to help hold it up. Better. Oh, you get some different leads for these, I think. It should make like swivel leads so they never get tangled up. That'd be nice, wouldn't it? 0.27. Bit low, but it's 0.6, so it's a bit low, but there's a resistor here. It's probably related to that. Let's go the other way. Yeah, I'm getting the same the other way. It might just be that. It's probably nothing. That's fine. Can't see anything that way. It's okay. So it's a bit tedious having to check every single part instead of actually doing like some logical testing. But sometimes you can find something which you weren't expecting. So although it's a bit tedious, That's it. I'm not getting a value from this one. Yeah, and now I'm getting a short. Q35. Try it the other way around. Yeah, okay. Q35 is probably stuffed. So this board might have several issues. This could be a fun one. Yeah, so as I was saying, sometimes you can just poke around, you can find something you weren't expecting to find. Where you can sit there and through, you know, try and logically go through the circuitry and go, oh, okay, that bit does that and that does that, and so on. And think about, you know, what you should be measuring and what tests you should be getting, what test results you should be getting. But sometimes you just poke around like this, and you'll find something like Q33. I'm hoping that there's actually not that many issues on this board, but it's not looking good. It wouldn't surprise me if there's lots of faults on this board. That's fine. Come on. Oh, okay, it's going. Just wasn't getting a measurement before. That's might be a different pin out. Yes, it is. Okay, so a bit tricky to get into. Another short. That is Q. Q, is it a D? That's Q. Q7. Yes, this is going to be long process. Long process. That's interesting. Getting the same both directions. .6 that way. Oh, there we go. Must have just not had it touching well enough. It's okay. Okay. There's some kind of, it's an AD3092, so it's probably a voltage reference. Oh look, more shorts. Or more perceived shorts. 0.64 that way looks okay. Short that way, Q38. Okay as well. Right, so I think that's all the semiconductors checked. As you saw, there's many things to look into. Yeah, very interesting. I'm going to have to look at these parts on the circuit diagrams and see if how they interconnect. There might be that there's like a cascade failure that's occurred, which is usually what seems to be happening with this thing. As one thing goes, it takes out a whole bunch of other stuff because there's no protections there. You know, sometimes even a little resistor in place in series with the circuit will just be enough, without like a fuse, or drop the current and then burn the resistor out. These things gives you exactly where you got to look for. You know, it's just, yeah, it seems there's no protection really being considered in this thing, which is a bit of a shame. So let's just check capacitors. We'll do that next. So I've got a meter out. Let's clip it on and try and get some shot at the same time. Yeah, barely. Here we go. Right, let's get started. 3.2 UF, 0.1. So 3 UF, so it's looking good. Pretty much the same, 0.2. Oh, that's a delta. Delta. I forgot what it's called now. It's terrible. Here's a D. No. I prefer using ESL anyway. It's only 11 ESR. Maybe they're not alright then. Showing a 5. So these are looking a bit dodgy actually. Based on ESR alone. There's no one over here. So that's 318 UF, ESR looks fine. And there's another one over here. 22 UF apparently. Yep, looks okay. $320 or so again. That's 330 marked. That's 330 marked. I think that's all the electrolytics I can see. I'm not missing anything. Right. Yeah. It's going to be interesting. I'm not going to worry about measuring anything else. Not for now. I may do resistors after I've gone through the other stuff, so I've got a whole bunch of stuff to check out. These need replacing, so I'll replace both of those if I've got some civil parts. 300 volt. That could be interesting. I probably don't have any civil parts. Oh well. Right, so I started looking at the circuit diagram for this board and to look at these various parts I found which I'm suspicious about. So before we start pulling parts, it's best to see what's actually on the diagram and see what's actually there. So the first one I've got is Q7. Now Q7 is here, and there we go. Look, it's got a link between the base and the collector on the circuit there. So that means that's a short. So that Q7 is probably fine. So I can cross that off. So I've got Q33 and Q35 next. Where are they? I found the other one so quickly too. Oh, I don't see them. There's 40s. Is that 35? This Q35. Q35 also has a link between the base and the collector. So Q35 is okay. Where's Q33? It's being hard to find. So 32. 31, 32, 40. Oh, where is it? Come on. I can't see it. Oh, we'll have to find it. Okay, let's move on. Q14. I'll come back to it. There's Q14. Now this has resistor. There we go, there's resistor between the base and the emitter, and the base and the collector. So 14 is probably okay. It's 1.86k there. So 14 is likely to be alright because it's got resistors across it. So I doubt that is blown. Q17, 19, 18, 17. 17's got a diode across there. That's okay. Not linked. There's a FET going across that connection. There's a parallel part on that connection. Would a FET give a short? Possibly. That's likely to. Yeah, that's probably going to be okay. 17 is likely to be alright. Pass it off. So now we've got Q38, Q19, Q33 left. Q20. Where are they? It's Q37. Might come back when I find them. Okay, Q38 is over here, and that is a FET. So it's possible that's actually okay as well. And there's only a capacitor between those two parts there too, a couple of capacitors, so 38 is unlikely to be failed. I'll put a question mark anyway, just in case. So we'll carry on. Now that CR17 which I measured, that's across Q17. So CR17 is the diode one I was suspicious of, and that means that's probably okay. So either both of these are gone, or it's fine. So I'll just do that. Okay, so here's Q19, and it has two resistors between the base and the emitter. So that's 100 ohms and 4.7 possibly ohms. So that's very low resistance, so that's probably going to be alright as well. So cross that one off. So it's looking promising. Just got to find 33. Q33 is this FET over here, so it's likely that's okay as well. It's entirely possible that's fine. So I didn't make just about everything really. The only things left are these diodes. Now we've got diode next to U2, and U2 is over here, and it looks like it is CR16. So it is U1, here's U2, there's CR15 there, which is across a relay coil. Where's CR16? Was that? No, that's 16. Is it? Because that's 15. One of those. I can't quite read that one. So 15 is okay, because it's across the relay coil, doesn't matter. Where's 16? I don't see it. There's a CR6 there. That must be 16. That one there must be 16. It's in the right proximity. So again, it's across a relay coil, so it's fine. So it won't be those. And the one by C35. C35 was here, and it is CR. Looks like 28. Looks like 28. So that is in this section here somewhere. Capacitors probably is in the spot first. Here we go. C35, CR28. It's actually directly across that capacitor and that resistor. So yeah, that's probably going to have a weird reading as well, because across the capacitor and a resistor. So that's probably fine too. So if all those parts are tested, everything looks fine. 38 I'm special because it's a FET, but yeah, it's probably right. Okay, so that method hasn't worked. I haven't thrown anything up as obvious anyway. Everything that measured badly, I can explain why. So I think I'm probably going to have to power this board up and do tests on the actual voltages that are on it and see what's actually going on there. I'm suspicious about this section here, which is a 90 volt regulator, or minus 190 volt regulator. Nothing came up as bad in the area though, so I don't know. But this has got like the current limit section in there. There's also current source up here, which is part of, which I measured being a bit weird. CR17, CR and Q17, and the limiter, which is triggered over here. So that's what shows up the overload section when the overload indicator's on. So that's part of U2. I mean, it could be U2's fault. It might be as simple as that, but I need to prove that by checking everything else first. So if I've got a 5 volt rail here and stuff like that, and so it does have test points on the board up here, some there. So I'm gonna have to just dig into it. I think plug the thing in. Now I've got the riser board has arrived, so I think I did that. So it's the riser, which should hopefully fit. It's for Fluke. I've soldered it all up, so I should be able to plug the board in mostly, and I actually tried plugging the board into it. Yeah, looks like it'll work. So yeah, I should be able to rise it up and then plug that into the unit itself, and then plug the board into this. So I'll lay the board, which way around that go, which is the size of which goes that way up normally, so it's going to be that side up like that, which is handy actually. Should be able to get to all the things I need to test on that side. So yeah, I think that's probably going to be the next thing to do, is use the riser card and try and do some actual testing on it. But yeah, the test point just there as well. So without anything being obviously bad, I mean, this has been, I've resoldered that and resoldered a couple of bits. I'm going to tidy up in here where you've got these parts which aren't fully in. I'm going to fix those up as well. That part there, make sure it's fully in, and just clean up anything. There's a lot of part there as well which isn't quite fully in, which is this one here. I'll just tidy all that up just in case it's not got a good connection through the wires, and just with all those issues out. I've resoldered around here, but it's not great. I need to use more flux and tidy those up a bit better. But you never know. Maybe what I've already done will fix it, but it's unlikely. Right, so I've removed this part here, which is the Q17, because it's badly soldered in. So I thought, well, I'll just desolder it and I'll refit it all, because the leg was all bent up and wasn't actually going through the hole. Like, so while it's out, I might as well just test it. This one has ones which are in a pair, which I was really suspicious of. So I thought I'll just try testing out a circuit and see what I get, seeing as it's out of circuit now. Give me some kind of no, what's the word I'm looking for? I don't know. Confidence. NPN resistor, it's fine. So, yeah, you probably can't see actually. Right, so there you go. That's what we come out with. It's fine. So what I might do, so I know, at least now I know this part is definitely okay. Now what it's actually got on the bottom of the board here is I measured a short between two legs, and this costs on the board there actually is a short. There's a connection between them, so that means that's probably fine anyway. So again, not a problem. So I'm going to refit this part again and put it in properly this time, like the past person that was on it, and at least I'm sure then at least that part's right. This is one I was most suspicious about, but yeah, let's try and get the thing back in properly. So that leg wasn't actually going through the hole before. Okay, I'll solder that back in. Got a big ground plane on this one, just here, big mass to try and heat up. have to use my other iron for that. I'll manage it fine. There's that pin sticking through right there, so it's now soldered properly. I actually use my desoldering gun for this because this will heat this up easy. There we go. And I'll have a bit more of a look around, see if I can see any more dodgy joints. I mean, there's a few here which I've just touched up a little bit, but yeah, I've done these with flux now, so it's a bit better. Oh, you probably couldn't see it on the camera. That's a bit stony. So yeah, so that one there's a big ground plane on that one there, so I'd use a big iron on that one right there. But yeah, I don't know, nothing found yet. As I look gluing these locators back on again, I actually use this stuff here, Selly's Monogrip glue. It dries really quickly, and it's quite strong and actually quite tacky. It will just you can just push it on, it will sit there quite nicely, and it seems to work quite well. Very good for things like this.